big country here, India and China, red. What does it mean? We are top on emitting BC, or black carbon, and organic carbon, and also the fossil fuel. I mean, this is the database that scientists looking at. This is since the year 2000, the most comprehensive kind of emission inventory that used in all the models that I work with, and many scientists work with. And if you look again in this population density, it explains what does it mean by having a lot more emission. The word is anthropogenic emission that we call. Anthropogenic emission is what comes from people activity, okay? And then you see, of course, high density of the people in these two regions, East Asia and South Asia. And therefore, if you look from 2000, and then if you look the projection, it's not the projection, it's actually the actual emission that has been recorded. It has been decreased, increased. The red line represents East Asia, and the pink line, South Asia, all is going up, which is against or opposite to the trend that you see from the other colors of the line, the blue and green, from Europe and USA. I mean, all the other countries are in North America and in Europe, they start to decrease or reduce emission. But happening now is increasing emission from our region. So then scientists, this is from Menxin. She's a Chinese working in the US. But she wants to say, what happened if emission increase in Asia? You can see this picture. This is the downward trend of the monsoon indices, or the monsoon index. Okay, a scientist used this parameter. I will not explain too much about this, but importantly of this message is that you see the decreasing trend in both the East Asia summer monsoon index, which means that you're going to have less precipitation or the rain that comes across East Asia, and you have also less rain in each monsoon season. Okay, in each wet monsoon season, summer monsoon, in both East and South Asia. El Nino was noticed by the unusually warm side on the cold season of the South America coast. Okay, and there's what we call upwelling. It means that there's the movement of the water under the ocean only in that particular time of the year, unusually warm, and then it's mean that the usually circulation of the water in the ocean push off the shore to be quite warm out in the ocean. And what is mean by warm, which means that it's going to bring the rain above. Wherever it's warm, then you have a tendency to have the cloud, okay? Because, and particularly on the ocean, you have a lot of water body. So when the wind blows across the water body or any wet area, then you get a cloud up, okay? So to just imagine that you have then its rain out in the ocean and not on the other side, which usually the wind will blow in such a way that we have wet area. So in the El Nino year, it's going to be unusually dry in where there should have rain, okay? Like in Southeast Asia, mentioned before this, I think this morning, yeah, about that. We have the problem with the, open burning, and this create a big issue on air pollution. Because instead of rain, we don't have rain, and then it's too dry, and then, vast area of forest fires or whatever, and then no rain to wash it down. Yeah, and that is the El Nino year. And this year is the year that El Nino is so strong, such that you got that piece of news. Okay, so in India, this is very important because then you don't have rain, not enough rain. And then what to do, right? The crop is now gonna die, don't yield. Yeah. And this affect, although because the Pacific Ocean is so huge, and then the impact go across the world actually. So it's not just the Pacific that the El Nino, which is the term for the it's ocean and atmosphere circulation, I would say. Its impact to South Asia, its impact to North America also. So at the same time, you have that piece of news in India. We have 2000, in this year, 2015, Chaitri Roy, she's a student, a PhD student in India. This is the result from atmospheric modeling, okay? They use this model to simulate, to show you that the aerosol induced rainfall anomaly, so which means that you have higher aerosol concentration. The meaning is that you have smaller drops. When you have more aerosols, you have smaller drops of the rain, and you have the whiter and more reflective clouds, and potentially it will delay the rainfall. Okay, because of the fact that you have the clouds, but you don't have the rain. Okay, you know, not only the normal dust, but you have it black. What happened? It's darkening the water droplets. So the water droplets is not white anymore, and then it will evaporate. It's even worse, right? Potentially, if you think logically, then you have even less clouds or not. So we want to prove that. Then, so this has been explained by what scientists discuss at ACAM as the word elevated heat pump, EHP, and solar dimming SD effect. This is just a simple diagram. So this gray area is the land, and this is the water. So in the normal monsoon, you have the sun moving north now. Then the sun starts to heat both the Himalaya and the land. And in the normal situation, then the wind start to blow in, and then the moisture coming from the ocean then start to get become cloud. So simply that it decreased the lower area rainfall, increased mountain rainfall. It changed the monsoon onset date. I'm not saying that when it's going to be happen. You have to catch what happened in each year, no? Okay, yeah. But scientists say that it's changing the monsoon onset date, and the pollution transport will be transported further across the globe. So now this is the international issue. So I'm just leaving at the end that can we get some new material to warm up the big conference, because we're going to have that one next year in March on atmosphere policy and mitigation. So hoping that you can, communicate to the people and telling them about how important what we are doing here in this Himalayan region and the impact that it will have on the, across the world about that. Thank you very much.